In this section, exponential and logarithmic models, we're going to be looking at application problems. I think you have about 5 problems in your homework set. So here are 2 examples to kind of give you an idea of what you'll be looking at. So number 1, the population of a fish farm is modeled by the equation P of t, where t is the time in years. So P is the population, t is the time in years. What is the size of the initial population? The initial population is the size at time 0. So what you're going to do here is just plug 0 in for t and get your answer. So 6,250 divided by 2 plus 23 times e to the 0.4 times 1. Oh, I'm sorry, times 0. It's times 0. So this is going to be e to the 0. Anything to the 0 is 1. 23 times 1 is 23. 23 plus 2 is 25. So this ends up being 6,250 over 25, which reduces to 250. So the initial population is 250 fish. Okay, what is the doubling time for this population? So how long does it take for it to double? So if originally your population is 250, we want to know how long it will take to make the population be 500. That's double the 250. So population is 500, and then we'll set that equal to the function it gave us in the beginning. Okay. And so now we need to figure this out. So we need to multiply both sides by the denominator. So we can get that off the denominator. All right. So that will give us 500. We're going to distribute this. So we'll have 1,000 plus 23 times 500, 11,500. E to the negative 0.4t is equal to 6,250. Then we can subtract 1,000. I did not give myself enough room to work this one out. So 11,500 e to the negative 0.4t is equal to 5,250. Divide by 11,500. So then we'll have e to the negative 0.4t is equal to that fraction. Then we have to take the natural log of both sides to get rid of the e. Okay, so then we'll have negative 0.4t is equal to the natural log of 5250 over 11.5, and then we're going to divide that by negative 0.4. So t equals whatever we get when we put that in our calculator. So let's see what that is. So I got 1.9602. It says to round to the nearest tenth. So it's actually going to end up being 2.0. So it'll take 2 years. T is the time in years, so 2 years. All right, number 1C. What is the size of the population after 4 years? So in this case, they're giving us the years. We just plug that in. So 6,250 over 2 plus 23 e to the negative 0.4 times 4. And when we plug that in, round to the nearest whole number, we should get 941. So after 4 years, the population of fish is 941. And then part D, how long will it take until the population contains 2,813 individuals, and round to the nearest tenth? So this one is going to be similar to part B. They give us the population this time, So 2813 is equal to our formula. Okay, so last time I did the long way all the way through. When you're solving this, you can just kind of interchange the 2813 and the denominator. So this is going to be the same as 2 plus 23 e to the negative 0.4t is equal to 6250 over 2813. So this is something that you can do. It might save you a little time. And so then you can subtract 2 from both sides. So that'll give you 23 e to the negative 0.4t is equal to, we have that fraction, minus 2. Notice I'm not even simplifying this or putting it in my calculator yet. You can if you'd like, but make sure you don't round in any of your intermediate steps. You have to keep the exact answer until the very end and only round at the very end. So now we'll be dividing by 23. So this will be e to the negative 0.4t is equal to this whole thing. Then we have to take the natural log. Okay, and then we have to divide by negative 0.4. And that gets us the t by itself. So this is quite a bit of information here. So you're going to do 6250 divided by 2813. Subtract 2, divide by 23, take the natural log, and then divide by negative 0.4. And if you're rounding to the nearest tenth, you will get t is equal to 11.6. Okay, so if this is kind of confusing for all the stuff written down, let me erase this and show you a different way you can do it. Okay. Keep in mind, as I'm working this, I'm going to be not clearing my calculator for each step. So if you start by writing 2813 is equal to 6250 over 2 plus 23 e to the negative 0.4t. Start with the same step as before. Interchange the denominator in the 2813. So 2 plus 23 e to the negative 0.4t is equal to 6250 over 2813. Now if you want to go ahead and do the 6250 divided by 2813 in your calculator, you can. You can write down an approximation, but do not clear your calculator. So you'll have 2 plus 23 e to the negative 0.4t will be equal to 2.2218. Now you're going to subtract 2 from both sides. Now keep in mind this is not 2.2218, it's longer than that in your calculator, and you're going to use that. Okay, so now when you have your calculator, you have the long number in your calculator, you're just going to hit minus 2 equals. Your approximation for your paper will be 0.2218, but again, do not clear your calculator. Then you will divide by 23. So that'll give you e to the negative 0.4t is equal to, so now you're going to hit divided by 23 equals. Your approximation for your paper will be 0096, but again, it's longer than that. You're going to leave it in your calculator. Now you'll take the natural log of both sides. So that'll give you negative 0.4t is equal to, so natural log of what you have in your calculator. Your paper estimate is going to be negative 4.6414, but again, don't clear your calculator. Now we're going to divide by negative 0.4, and that will give us t. So divided by negative 0.4, and that gives us our 11.6. So if you like to do it this way better, that's fine. Just remember, do not clear your calculator on the intermediate steps. The second example I'd like to walk through is a doctor prescribes 200 milligrams of a drug. The amount of the drug in the patient's body decays by 20% every hour. Part A, write an exponential model for A of t, the amount of the drug in the patient's system after t hours have passed. So we can have our basic, remember this is exponential growth and decay, so the basic formula, something like that, where P is the initial amount, R is the rate, and T is the time. So in our example, we know our initial amount is 200 milligrams. Okay. And now what we want to do is use the fact that we know it decays by 20% every hour. So when T is 1, after 1 hour, 20% of the 200 milligrams will have decayed. So 20% of 200 is 40. So 200 minus 40 is 160. So after 1 hour, there will be 160 milligrams left in the body. So we're going to use that. 160 is equal to 200 e to the r times 1. So we can get rid of the 200 by dividing both sides by that. We will have e to the r is equal to 0.8. Then we need to take the natural log of both sides. So that'll give us r is equal to the natural log of 0.8 is negative 0.223144 if I'm rounding to 6 numbers after the decimal place. Okay, so I needed to find the r in this way so that I would have it for the formula. Because in the formula, you want to have a p and an r. The e is going to stay an e because that represents an actual number like pi. And then the t is going to stay a variable. So our formula will be A of t. So the amount of drug at time t will be represented by 200 e to the negative 0.223144 t. So there is our exponential model. Part B is use the formula that we just found to find the amount of the drug remaining after 3 hours have passed. Round your answer to the nearest tenth. So T represents time, so we're simply going to put in 3 for T. So 200 e to the negative 0.223144 times 3. And when we put that in our calculator, we should get 102.39986. It says round to the nearest tenth, so 102.4. Okay. Now part C. What is the half-life of this drug? Round your answer to the nearest whole number. So the half-life is the amount of time it takes for half of the original amount to decay. So this means if we started with 200, we want to know how long it would take for there only to be 100 milligrams of the drug left. So the amount will be 100, and then we'll be solving for T. Okay, so to solve for T, we're going to divide by 200. You will see we end up with 0.5, which is the half-life. That's why you get that. Is equal to e to the negative 223144t. Then we need to take the natural log of both sides. So that would leave us with negative 0.223144t is equal to the natural log of 0.5. And then divide by that negative 0.223144. And when we put that in our calculator and round to the nearest whole number, we will get 3.